Hello, and welcome to the Innovation Coffee Break. My name is Peter Ngure, and I am the product manager responsible for RT-Maps at DSpace GmbH. RT-Maps, or Real-Time Multi-Sensor Application, is a safe software development tool from early prototyping up to production. RT-Maps has been used in different industries to quickly prototype and execute multi-sensor applications, using a graphical user interface and taking advantage of the rich library of sensors that is contained in the tool. Today, we will have a look at the application of RT-Maps in automated mobile robots. Giving mobile robots autonomy is quite important for both economic and safety reasons. For instance, AMRs find important application in working environments that can be considered to be unsafe for humans. In order to attain autonomy, mobile robots need to use sensors to perceive their environments, and then use perception algorithms and path planners to understand their environment and plan their motion. To understand the application of RT-Maps in automated mobile robots, let us look at the architecture of AMRs. Their functionalities can be divided into 4 broad sectors: sensing, perception and fusion, driving functions, and actuation. RT-Maps offers out-of-the-box sensor and I/O devices interfacing, and with RT-Maps AI Store, it is possible to access different types of perception algorithms to use together with your AMR based on the application of the given AMR. The application developed in RT-Maps can be executed in embedded targets using RT-Maps runtime engine, and the applications or the diagrams that have been developed can be accessed and modified remotely using the Remote Studio connector. RT-Maps can run on Windows, on Linux, on embedded Linux, or even in QNX RTOS. For our demo today, we will show how Nexiard's free space calculator can be used with simulated mobile robots. Nexiard is a DSpace partner that offers perception algorithms, and these algorithms have been made available to users of RT-Maps in the RT-Maps AI Store. First, let's have a look at the architecture of this demo. DSpace Aurelion provides the simulated sensor data and motion data, and this data is fed into RT-Maps for pre-processing. The computed free space is then fed back into the simulated AMR to control its driving functionalities. Let us have a look at the demo inside RT-Maps. On the screen, you can see RT-Maps Studio. Let's pick up how RT-Maps work, or how it looks and its functionalities. On the left-hand side, there is the registered components that are ready to use with RT-Maps. Down in the left-hand side, there are all the libraries for RT-Maps that exist. There are over 600 of them. In this section here, we have the properties where you are able to interact with your components or with your algorithms. The console gives you the communication, or gives you the feedback from your algorithms when you have errors for easy debugging. In the white space, this is where you work with RT-Maps. This is your free space to execute your RT-Maps diagrams and applications. It's quite easy. In this case, we are interested in Nexiard's NV Vision, which is here. And we just drag and drop the application, and again drag and drop any application or any application from Nexiard that we would like to use, like so. And if you wanted to do connection, it's also quite easy. You do connections quite easily with RT-Maps for your interfacing. And even for the display, this is quite easy. It's the same thing. You have to connect them as shown in the diagram. So if you want to interact with one of the Nexiard's components, you just click on it, and then you can go down here and look at the properties that are therein, and you can change them. And now I will show you the demo in a complete version. So this is the complete demo. And as you can see on the screen, we have 3 sensor streams. The first one is the LiDAR stream from Velodyne, or simulated LiDAR stream from Velodyne, which is pre-processed using Artimap's Velodyne decoding components, and then we can visualize this. And to have the top view of our AMR, we also have one camera streams. We just go into the Artimap's viewer. One of the camera streams goes directly into the Nexyard's pre-processing, which feeds its output into the Nexyard's free space calculation. The output of this we can visualize, or we can push it back to the AMR in a closed loop version for it to execute its driving functions. And now I'm going to start this diagram so that you can see or visualize how this works. The video on the top right hand, we see the visualization of the free space calculator. The Nexyard's algorithm computes the available free space based on the camera streams that it receives. This information is then fed back into the mobile robot, which uses this information not only to plan but also execute its route. The right-hand corner shows a top view of the AMR's motion, and we can see it moving within the warehouse and avoiding obstacles in the warehouse. To recap, Artimaps offers a platform to easily develop applications and run them on embedded targets. A graphical user interface that reduces software development complexity while encouraging collaboration within teams and with partners, and offers over 600 sensor and I/O devices supported out of the box. Please feel free to contact us for evaluation licenses and dedicated demos. Thank you for joining us and listening.
DSpace, your partner in simulation and validation.